Last time we were looking at a plus b quantity squared and a minus b quantity squared, and then a minus b times a plus b. And if we use the FOIL method and multiply these out, let's see, a plus b quantity squared would be a plus b times a plus b. Now, many students will say, they'll make the mistake of saying that a plus b, or a minus b, a plus b quantity squared is simply a squared plus b squared. But you see, when we use that FOIL method and actually work these out, yes, I do get a squared, and I do get b squared. But I also get this middle term, b times a plus ba, and then I get a times b plus ab. Now, we know that AB or BA equals AB, so then really what I've got here is AB plus AB, or let's just erase this. Or I've got AB plus AB, or 2AB. And that's basically the same thing then that I'm going to have here, is I'm going to have a squared minus 2ab plus b squared. Now, why the minus and why the plus here? Well, negative b times negative b is going to be positive b squared. A times a is, of course, positive a squared. And here I've got negative ab, and here I've got negative ab, so I've got two of them. But now notice, on this last problem, when I use the FOIL on this, I'm going to get my a squared in front, and I'm going to get my b squared in back. Actually, it's going to be negative b squared, but the two middle terms, negative ab and positive ab, subtract each other away, and I don't have a middle term. This is the difference of two squares. Okay, now let's use this example. Well, let's just do a couple of them. So if I've got 2x plus 3 squared, what's that? If I've got 5x minus 7 squared, what's that? If I've got 6x plus 3 times 6x minus 3, what's that? Go ahead. Take your time and you do them. If I don't use the FOIL method and I simply use this formula here, I can see that a plus b squared, that quantity squared, is a squared and a b squared on the end. So there I'm counting this is a. So 2x squared is 4x squared. And in the end is 3 squared is 9. And then 2x times 3 doubled. Well, 2x times 3 is 6. 2x times 3 doubled is 6x. 6x, or I'm sorry, 2x times 3 is 6x, and then double that, and I get 12x. Same way here, I'm going to have 25x squared, and I'll have a 49, positive 49 on the end, and then 5 times 7 is 35, double 35, and I get 70. 5 times negative 7 is negative 35x, and then I'll have negative 70. On this one, the two middle terms are going to cancel each other out, so I end up with 36x squared minus 9. Now, if in doubt and you don't see that formula use, you can always take these problems when they say something squared and simply write them out and use your FOIL method and multiply them. And you will get the same answer as this. You'll get that exact same answer. Okay, now let's talk about factoring. Let's talk about factoring. Okay, be right back. What would you do if you were asked to factor this trinomial right here? Well, if we compare this trinomial here to this, we see, oh, that doesn't quite fit. That's not the same. We compare it to this one right here, we say, oh, I need a negative right there. Compare it to this the first problem right here, and we say, yes. Remember, this was wrong. We say, yes, this could fit the form. I have a b squared. I have a 25, which is a square, and I have a square here, a squared. Do I have 2 times a times b? Well, let's think. This would have been x and plus 5 and plus 5 is 5x plus 5x 10x. Yes, it is. So here we have x plus 5 squared. There'd be my factored form, or this could be it too, for that matter. This would be okay too. Okay, so then what if we have the same instructions? Factor this trinomial. Again, I look at these formulas and say, this one doesn't quite work. This one might work. I have a squared term here. So this must have could it have come from there? Does 2 times a times b, 2 times x times 7, 2 times 7 is 14, 14x. Yes, that would be it. All right, what about this? Again, I have the directions to factor, and I have 25x squared minus 36. Doesn't fit either one of these forms, does it? Doesn't fit that form, doesn't fit that form. So, but it does fit this form because this is a perfect square, 5x. This is a perfect square, minus 6, 5x plus 6. And our check, there's negative 30x, there's positive 30x, negative 30x plus positive 36. 30x is no x's, hence no x's in there. Now, the hardest of all factorings, all of these would say factor, are these trinomials. Now, sometimes a trinomial doesn't factor, but very often it does. And these are the trinomials that are not perfect squares or are not the difference of two squares. So we have to think this number right here is a product. So this number right here is a product. This must be x squared. What times what? What are two factors of 6 that add up to be 5x? Because this system, this inner and outer, are added up. Well, 1 times 6, 6 times 1, those both add up to 7. 2 times 3, 3 times 2. Aha, those both add up to 5. So this could be a plus 2 and a plus 3. Or could be the other way around. X plus 3, x plus 2. Here we go again. I'm going to multiply two binomials together. I know they start out with x times x. And then I look at 12 and I say, well, that's 3 times 4 or 2 times 6 or 1 times 12. Well, 3 plus 4 is 7. That would be it, wouldn't it? 2 plus 6 is 8. That's not what I want. And 1 plus 12 is 13. That's not what I want. So this would be plus 3 and plus 4, or the other way around. Now, notice something here. Let's use these other examples that we just put up or from our factor chart. What if we would have had x plus 2 times x plus 6? That would have been the factoring that would have come from 2x plus 6x is 8x. or x plus 1, x plus 12. 1x plus 12x is 13x, and 1 times 12 is 12, and x times x is x squared. Are there any others? Do you see any other factors? Other than turning this around to make this 6 and a 2. Now, this problem right here, I have a different situation. If I have a negative 6 on the end, then this must have been a plus term, a plus number, a positive number. This must have been a negative number. Well, what two factors of negative 6 that add up to be positive 1? Well, I could have positive 2 times negative 3. Positive 2 plus negative 3 would be negative 1, but positive 2 minus 3, that would certainly fill up the negative 6 part requirement, wouldn't it? But notice then this is 2x, and this right here is negative 3x, which is a total of negative 1x, but we want positive 1x. So simply turn these two things around right here. Make this one negative. Make this one positive. Then I've got negative 2x, positive 3x, positive 1x. So we can kind of learn or work the problem by trial and error. Let's do another one of those that we did before. What would this be? X squared plus 1x minus 12. Okay, what two factors of negative 12 add up to positive 1? Be 4 and negative 3, wouldn't it? So we'd have x plus 4x minus 3. Another one would be plus 12x minus 12. What two factors? I've got plus and a minus. What two factors of negative 12 add up to positive 12? Or rather, I think I mean 11 here. Got the wrong number. Well, I could say positive 12 and negative 1, they multiply to negative 12 and they add up to positive 11. So there we go, positive 12, negative 1. How about this one? X squared minus 13x, this should have been x, 13x, plus 12. Now, what two factors of positive 12, what two factors of positive 12 add up to be a negative 13? Well, if I took negative 1 times negative 12, that would be positive 12. And if I add them up, I get negative 13x. So this will be x minus 1, x minus 12.